Multiplexer, or MUX, is one of the most fundamental building blocks of a ternary computer. So today, let's see how to simulate a MUX in Logisim. Because Logisim is built for binary logic circuits, we have to use 2 bits to represent a ternary trait. We'll use the hexadecimal 1 to represent +1 or A, 0 to represent 0 or O, and 2 for -1 or V. The multiplexer itself has 4 inputs and 1 output. They are labeled P, M, N, S, and C. The first 3, P, M, and N, are the data input. S is the select input that controls which of the 3 channels are hooked up to the output. When S is +1, the output is connected to the P channel. When S is 0, the output is connected to the M channel. And when S is -1, the output is to the N channel. Down below here is a buffer circuit, the simplest circuit that can demonstrate the function of the multiplexer. We'll also be using this circuit when testing our actual hardware. We can see that the switching effect of S on the output C. C will always equal S. And when we flip the input P and N channel, we have changed the buffer into an inverter or a NOT gate. The output will always be the negative of the input S. And this is the internal of the multiplexer element. I used a regular multiplexer provided by Logisim and leave the 4th pin unattached, as we only need 3 inputs. So when we set S to be all ones, the output will generate an arrow, which is pretty convenient for debugging later on. So the next step is to build an actual multiplexer on the PCB.